Hey everybody, Mr. Dickman back again. Today we're going to talk about combinations, which is a different kind of counting. So let's start with a warm-up, similar to what we did on the last video. The ice cream stand at the state fair has 4 toppings: sprinkles, fudge, Oreos, and peanuts. You are ordering a 3-topping sundae. How many different sundaes can you get? Let's list all the possibilities. Just like last time, we could have gotten sprinkles, fudge, and Oreos. We could get sprinkles, fudge, and peanuts. We could get sprinkles, Oreos, and peanuts. We could get no sprinkles, just fudge, Oreos, peanuts. We could get, let's see, what else is there? Are there any other combinations? I think that's it. Those are all the different ones you can order. And remember, getting sprinkles, Oreos, then fudge is not any different. You're not actually looking at it to say, well, you put this one on first. So there's only 4 different sundaes that you could get with 4 different toppings. Kind of crazy. How as soon as the order doesn't matter, the number of possibilities goes way down. So let's talk about combinations. So a combination is an arrangement of objects in which the order does not matter. The warm-up's an example. It does not matter what order you put the toppings on the sundae. It's still the same sundae. So let's do an example. And that example is how many ways can you make a hand by choosing 3 cards from a deck of cards? Okay. Well, how many cards are in a deck of cards? Hopefully by now you know this. Okay, so there are 52 cards in a deck. And I am choosing 3 of those cards. Okay, so that means there are 52 cards for me to choose from when I pick my first card. But then, when I pick my second card, since I've already picked one of the cards, there's only 51 cards left. And now that I have picked another card, for my third card, there are only 50 cards. However, when I look at the cards in my hands, I can move them around in any order, and it doesn't change my hand. So let's just say I had a 2 of diamonds, a jack of hearts, and a king of clubs, also known as puppy feet. Okay. So these are my 3 cards. Now if I take it and I keep it in this order, that's fine. Now if I arrange the jack to come first and then the king and then the 2, or the king to come first and the jack and the 2, it doesn't change my hand. It's still the same 3-card hand. So I want to make sure that I divide out all the different ways that I could arrange 3 cards, which is what we talked about last time. That is 3 factorial. So I'm going to divide out 3 factorial. So not only am I doing a permutation, because remember, to get 52 times 51 times 50, I'm actually going all the way down to 2 times 1. Okay, I'm going all the way down 49 times 48 times 47 times 46, which is 52 factorial. Then I'm dividing by 49 times 48 times ... 2 times 1, and that cancels out all of this to give me the 52 times 51 times 50. Now that would be a permutation. But what I have to do is I also have to divide by the number of ways that I can arrange 3 cards in my hand. So this is going to be 52 factorial divided by 49 factorial divided by 3 factorial. So remember, the permutation formula was n factorial over n minus r factorial. Now we still have that, n factorial over n minus r. 52 minus 3 is 49. But then we also have r factorial that we have to divide out so that we get rid of all the different ways that we are arranging 3 cards in my hand, or r cards that I have in my hand. Okay, so that gives me this formula. So combinations, I'm going to use this notation a lot. I'm also going to use this notation a lot, which does not exist for permutations. So I'm going to use this notation where n is the top number and r is the bottom number. Every time I use that, I'm going to say like 52, choose 3. And I'm going to use this notation. I'm going to say 52, choose 3, like this. And you'll know that I mean NCR, so 52C3. Now, if you're looking for this on the calculator, it's in the same spot that permutations were. You're going to go to math, over to probability. Number 3 is NCR. And you can type in 52, choose 3. And you get 22,100. I don't think I actually ever gave the answer here. So the answer here was 22,100. There's 22,100 different hands that you can make just by choosing 3 cards from a deck of cards. If I chose 5, if we talk about a standard hand of poker, 5 cards, that's 2,598,960. 2,598,960. So there are that many different hands that you can get in poker, choosing 5 cards out of a deck of 52 cards. That's what makes some of these hands so difficult to get. All right, so let's move on to another example. One of my favorites. I love pizza. So a pizza shop offers 12 pizza. So 12 different toppings for their pizza. How many different 3 toppings pizzas can you order from those 12 toppings? So this is very similar to the ice cream. If I order a pizza with sausage and eggplant on it, let's say sausage, eggplant, and tomato. Love that pizza. I'm not going to know if they put the eggplant on first before the sausage, or if they put on the tomatoes before anything else. The order is not going to matter. As long as I see all of those 3 things on my pizza, I'm going to say, hey, this is the pizza I ordered. And so what I'm going to do is 12. There's 12 toppings to choose from, and I'm choosing 3. How many different ways can I do this? I could also write this as 12 choose 3. And 12 choose 3. I'm just going to use my calculator. Type in 12C3, and I get 220. So there's 220 different pizzas I can make from those 12 toppings if I'm choosing a 3-topping pizza. All right, so in this example, we are at a restaurant and we're trying to figure out how many different omelets we can order. Specifically, we're looking for how many different ways we can order an omelet that has 2 vegetarian ingredients and 1 meat ingredient in the omelet. And these are our choices in the table above. So we want to figure out how many different omelets we can order. Since we don't care which order the person preparing our omelet puts the ingredients into the omelet, this would be a combination and not a permutation because the order doesn't matter. We're not going to send it back if they put the onions in before they put the bacon. So we need to figure out the number of ways we can order the vegetarian ingredients, and we need to find the number of ways we can order the meat ingredient. And once we have those, we're just going to multiply them together like we normally do, because for each combination of veggies, we'd have 4 different meat combinations, so we're going to multiply them together. So to find the number of ways that we can order 2 vegetarian ingredients, there are 6. 1, 2, 3, 4, 5, 6 different ingredients, and there's 2 choices that I'm making from those 6. Now in a previous video, I showed you how to use Excel to calculate combinations and permutations. So I'm just using the combin function right now to do 6 choose 2, and that gives me 15. And then the number of ways to order meat, there's 4 meats to choose from. I'm choosing 1, so that's going to be 4. And 4 choose 1 is just 4. There's 4 different choices. And so 15 times 4 is going to be the number of ways that I can order this omelet. So there's 60 different ways. So now let's figure out the second one. Let's just say I don't have a ton of money, so I can order at most 3 ingredients in my omelet. We want to know how many different omelets there are. So again, there's 6 vegetarian ingredients, there's 4 meat ingredients, so that's just a total of 10, and I don't care, I don't have to have a specific number of vegetarian or meat, just out of the 10 ingredients, I want at most 3 ingredient omelet. So to count this up, I need to know, first of all, it says at most. So I could have a 1 ingredient omelet, and then I could also have a 2 ingredient omelet, and then I could also have a 3 ingredient omelet. So I'm trying to figure out the total number of ways this can happen, and I have to add them all together. So the number of 1 ingredient, because a 1 ingredient omelet is different than a 2 ingredient omelet, and which is different from a 3 ingredient omelet. So if I have 10 ingredients total, I can choose 1. That's going to give me 10. I'm going to add that to, if I have 2 ingredients, there's 10 total. I'm choosing 2. I'm going to quickly do my combin here to figure out what 10 choose 2 is. So that's 45. And then I'm also could choose 3 ingredients from that. And again, I'm using my combin function, 10 choose 3, gives me 120. Now, if you wanted to, you could also say that I'm just going to order an omelet with nothing in it, just eggs. And I guess there's one way we can do that. So that's the number of 0 ingredient omelets. I actually used to order those as a kid. So we have 165, 175, 176 total. Different ways that I could order an omelet if I only have the money for at most 3 ingredients. All right, I'll see you in the next one.